Okay, so those of you who are on the case will have already had a little sneaky look at chapter 2 in the book, and you'll see it's, again, a familiar chapter. It starts off talking about quadratics. And so that's where we're going to start. We are not going to go through solving by factorising, solving using the formula. Those are still important skills, but you know, we were ready for those at GCSE. And don't forget also that we actually can use the calculator to solve quadratics now, unless there are horrible missing values in there. So I'm just going to start with a quick recap of quadratics in disguise. We did it just the other week. And I've got a couple here. If you remember the one we did a few weeks ago, there were two ways of solving the last one. I've got a couple here. You could use both methods with both of them, but I think one method is best for one and one method is best for the other. So for this one here, I'm going to line it all up. And then I'm going to replace the square root of x with y, make that substitution. So this becomes y, and x is the square root of x squared, so that is 3y squared. And I almost certainly could factorise that, but I'm going to remind you how to use the calculator. So we go into equation mode. This is a polynomial of degree 2. Its degree is the highest power of x, or y in this case. So I've got 3y squared plus 1y minus 14. And then those are my two solutions. And remember, if you have one that doesn't look very nice, look down here, gives it to you quite nicely. So I've got y is 2 and y is minus 7/3. So that actually means that the square root of x is 2 and the square root of x is minus 7/3. And if I wanted to know what x is, I just need to square that. And there's no plus or minus when you're squaring, that's just when you are square rooting. So, and similarly here, I can square this. I wouldn't be able to square root that, but I can square that. So I just think of it as a fraction multiplication sum. Minus 7/3 times minus 7/3 gives me minus 7 times minus 7 is 49. 3 times 3 is 9. Those are my two solutions to that one. This one here, it's much harder to do it in this form because the square root covers two things, and you can't just separate that into the square root of 8x minus the square root of 15. It's not the same thing. So I'm going to use the approach here of squaring both sides. So if I square this side, get x squared, and if I square this side, it just undoes the square rooting. So I've squared both sides. Now I can line it up. And this one, well, okay, this is one I am going to factorise, but you could use your formula. Here's another place where we meet quadratic equations. And again, we've done this at GCSE, but maybe it's a little bit harder now. But they are geometry problems, shape problems, where you end up with a quadratic equation. So here I've got a right angle triangle, and I'm told that its area is 9x plus 3. Now they've caught me out by, or trying to catch me out by writing it, or by drawing it like this, but if I sort of spin it around, you can see that I've got a base and a height, and I know the area of a triangle is base times height divided by 2. So I can straight away say, okay, 5x minus 3, that's the base, times the height, divided by 2 equals 9x plus 3. Now I'm going to pause at that point and get you to see if you can get somewhere with that. Grid it out, and then remember how I feel about fractions. Okay, pause now and have a go. Okay, so this is where I've got to. I gridded out the numerator there to get 5x squared plus 7x minus 6. That's all divided by 2 equals 9x plus 3. Remember what we're doing, based on height divided by 2 equals the area, and we're told the area there. Hate fraction, so I multiplied everything by 2, which just killed the fraction on this side, and on this side I had to remember to multiply both things by 2. Then I lined it up, took away 18x, took away 6. 7 take 18 is minus 11, and I'm about to solve it. So I go to my calculator and I have typed in A is 5, B is minus 11, C is minus 12, and I press equals and I get my two answers. So I've got two possible answers. X could be 3, or X could be minus 0.8, minus 4/5. Now if I go back to the original problem up here, if X was minus 0.8, then these would both be, well no, that one wouldn't, would it? The height would be okay, but that would be negative. So it can't be minus 0.8. X has got to be 3. So that doesn't mean I've got that bit wrong, but that's the only valid solution. So if I go back to my diagram, now I know that X is 3. 5 times 3 is 15, take away 2, that's 12. Take away 3, sorry, that's 12. And that's 5. So if I then use Pythagoras, 12 squared is 144, plus 5 squared is 169. So the square root of that gives me 13. So that's just, I've just used Pythagoras there. That squared plus that squared equals that squared. And so the exact length of the hypotenuse is 13 meters. So I've attached 4 questions in a PDF. Here they are in case you're watching the video and you haven't got that PDF. So there's 2 quadratics in disguise questions. That one's fairly straightforward. This is really fiddly, and I look forward to you having a go at that one. And then I have included 2 quadratics and geometry questions, and you'll have to remember how to find the area of a trapezium, but again that should be something that we're okay with. And there's going to be a little bit of surd action in that one as well. So again, you've got one which is relatively straightforward. I mean, we're at A level, so nothing's easy. And then this one, which is quite a bit harder. So there's plenty there to keep you busy. I am going to post solutions for this at the end of today. So it's Monday today, and I will put solutions for this up by the end of the day on Monday. So it'll be both by email and on class charts. Take care, and I'll see you again on Friday.